Good afternoon, everybody, and good morning for some. I'm on the East Coast, so it's just making afternoon, but I know we got people from uh, all reaches here. But just want to let you know here, we're going to talk about different heat sources for the brew house. My name is Kevin Weaver, president of Brewmation, and I'm here with Mike and David. I'll let them introduce themselves. They're going to also talk about some of the heat sources.
Thanks, Kevin. This is Mike Palladino from Stout Tanks and Kettles. I'll be talking later in the presentation about gas fire, direct and indirect fire, and I'll be following David. So.
Good morning slash afternoon, all. I am David Antonacci with Columbia Boiler. I'm probably the newest to the beer scene here, and I'll be discussing steam heating for your breweries.
All right. Okay, so what we're going to do, I'm going to start off, kind of give you a little overview. I'm going to take my camera off so we can make the screen a little bit bigger. So again, we're talking about the heat sources for the brew house. We're going to go through the three main ones here, which is electric, over here, electric, steam, and direct and indirect fire. So we just got a couple pictures on the right, just kind of giving you an overview of what we'll be talking about. So I'll get right to it. I'm going to go ahead and give you a little bit of overview here that obviously it's a pretty big decision when you're looking to put in a brewery. You're going to take a look at what you're doing, and then you really have to make a choice of which heating means you're going to do. And in some cases, combination of heating means. It doesn't necessarily mean that you're going to do all one, although most folks do it that way, but we've done plenty of hybrid systems. So a lot of things to consider there when you're making that decision. The size of the brewery probably being the biggest one. If you're doing smaller breweries, then you have a more of a range. But once you start getting into some quite large breweries in the 20, 30 barrel plus, then your options start to become limited. Primarily steam at that point. Space requirements is a very, very big consideration when you're looking at which of the systems to put in, which of the heating systems. And we'll talk about a little bit on which ones will take up less room, and a little bit about some of the infrastructure that you'll need for any of the three heating methods. Equipment cost is certainly a big consideration. How much putting in these systems is going to cost relative to your business plan. And installation cost becomes a very big consideration too, where your capital outlay for the equipment may be low. Installation on vent fans and things can start adding up. And then there's the operating cost. If you start plugging in numbers to your business plan, exactly where do you fall with your energy costs? Because that's what brewing is, putting in a lot of heat and taking a lot of heat out. Availability of utilities is certainly a big consideration. If you're looking at what's available for electric, if you have natural gas, if you don't have natural gas and your electric is high, for instance, in the Caribbean, you might be looking at propane, et cetera. And another very important one is the level of automation that you're currently looking to implement into your system. Each one of these heating sources has some pluses and minuses to automation, and we'll get into a little bit of that too. All right, so I'm going to jump right in. I'm going to be doing the electric portion of things, so let's get started on that. So electric heat. I've been myself working with electric systems since probably the year 2000. Started our business here in 2003 with all electric breweries. So kind of been through a lot of the trials and tribulations of electric brew houses and how to make them into the mainstream. And as I think a lot of you know, there are quite a few electric breweries out there at this point in time. It's become a very affordable, easy, controllable way, especially on the nano breweries, and definitely on microbreweries, and even breweries up to 15 barrel. So far, we've done. I'm sure there's larger ones out there. I know, we have designed 20 barrel electric systems, but it's just a matter of utilities that have to be considered at that point where it's feasible. So system size could be any size, like I said, up to 15, 20, perhaps beyond. Talking about my experience, 15 has been the largest ones that we've done, and done several of those. They worked out very well. A lot of people don't really think about electric for the larger breweries, but they could be very efficient. They can work very, very well especially if you have very decent electrical costs, and so on. One of the nice things, another nice thing about electric heat is it is the smallest footprint in all of the brewing systems. Where you're running electricity, your elements are inside the vessels. And as far as external devices, there really are not any. You don't have a boiler room taking up space. For direct fire, you have your gas burners that are going to require certain air requirements and airflow, so it becomes more of a space constraint that way. So I'm not saying any of them are a bad choice, obviously, but if you have a very, very small space, especially when you're considering how much heat is being emitted from the brew house, electric is a very nice way to go because you're not losing a lot of that heat to the space, so it's not overheated. We've had several customers who started out with direct fire in very small places and were not able to put in the proper ventilation and ended up switching over to electric. So you have a very small space, electric is certainly something to take a very good look at. It also is very efficient. So when we're looking at direct immersion heaters, all of that heat is going, or the majority of that heat, 99% plus, is going right into the liquid. So we're looking at nearly 100% efficiency when you're looking at electric. It's a very simple calculation of resistance to how much voltage you have, and your amps are, in essence, what your power is that's going directly into the liquid. So it definitely is the most efficient of the three. Low equipment and installation costs. Typically it is. Sometimes it could be a costly install depending on what kind of power is already in the space. So if you need to do a major upgrade to your power coming in, that may not add to the cost as much as you may think, because a lot of times the utility companies are willing to bring in new power lines because they know they get a new customer who's going to be giving them revenue on a daily basis when you're brewing. So a lot of that capital cost can be absorbed at times, a good majority of the time actually, from the electrical company. And also, when you look at the internal work, if you're adding a new brewery, electric brewery, you may not have to come up with a whole new electrical service. You could run that line coming right from the street through your meter and directly into the brew house. That has turned out to be a wonderful way to go, so that this way the existing power that's in that building can be used for the chiller, kitchens, whatever, HVAC, whatever else you have. So that's one thing not to be scared away on electric. You can certainly upgrade your power, but sometimes it's definitely cost prohibitive. We have folks that are living out on a farm that if they're bringing in power, you could have 2 miles of electrical lines that need to be put in. And if the electric company is not willing to do that, that could be very costly. So that could turn you away from that particular technology. Also with electric, it has a very high level of automation possibilities. Hot liquor tank timers is a great example where you could set your electric elements to turn on a couple hours or an hour or so before you come to the brew house, so you're all ready to roll. Has a very quick heating response, so very easy to control. Rims type situations, step mashing, very precise control of the kettle heat. Get into a lot of that, but the automation's easy because we're looking at electric, and we don't have to worry about a lot of the latent heats and whatnot. So it's a very, very easily automatable technology. And another great advantage there is that there's no carbon emissions at the brew house. Obviously, the electricity has to be generated somewhere, but as far as in the brew house, you don't have to worry about any carbon emissions and emission points. A lot of times in California, as an example, that can become an issue. So electric almost gets forced in some situations based on carbon emissions and some of the other technologies. So some considerations when putting in electric and evaluating an electric system to make sure that it is right for you. We are dealing with electricity, and even I've been around electricity pretty much all my life. Even when I was young, sticking a fork in an outlet, it's not fun, so you have to be protected. So with electricity, there are things that we feel that are a must in a brew house. You're dealing with liquids, you're dealing with electricity. So the first very clear item is to have GFCI protection on your systems. And that can come in different forms. GFI protection can be part of your breaker panel feeding your brewery, However, that is usually only going to work out maybe up to a 1-barrel system, because your breaker sizes that are available for most GFCI breaker sizes available usually are not very high. So if you're looking at a 150 amp 3-phase system, you're not going to be powering a 150 amp 3-phase GFI to the brew house from your distribution panel. So a nice design there is to put GFCIs inside the control panel as part of the design. That's what we employ in there. There's different ways to do that. I know some manufacturers handle it as a whole. So there's GFCI protection that will shut the entire panel down if there's an issue. What we employ is individual GFCI protection. So if there is an issue with one element, just that one element will turn off and doesn't disrupt the entire brew session. So either way, I mean, there's different ways to look at it. But the important thing is to have the GFCI, and not only have the GFCI, but make sure that that GFCI is the proper GFCI. There's a such thing as arc protection, and arc protection will protect equipment, but it does not protect for personal injury. GFCIs are the ones that protect for personal injury. And what that, how you determine the two is you take a look at what the milliamp rating is. And what that means is at what milliamp imbalance will that GFCI trip. So safety GFCI will trip at 5 milliamps if it determines that that's going somewhere where it's not supposed to, i.e. through your body. 5 milliamps is below the threshold of having heart issues or whatever, based on, that electricity passing through your heart. So that's why that 5 milliamps is the threshold, because it's a safe threshold. Anything above that can cause all sorts of issues. So very important to have the correct GFCI. So I would encourage anyone who's looking to do electric to do the homework and make sure that the GFCI is a true GFCI and not an arc protection. The other part of it is the UL or CUL. So UL is the Underwriters Laboratory. CUL is for Canada. So basically we have all of the Americas covered, North and South America, included in UL or CUL. And what that does is it ensures that the system is built safely. It's built according to code. Because when you're dealing with electricity, you're dealing with a lot of heat. There's a lot of design considerations that goes into the panel. So when you see that UL stamp, you know that it was third-party reviewed, that UL approved of the design, and therefore you should feel covered that you have a very safe electrical panel. And that holds true for all of the different control panels. It's not just electric, it could be for the steam and direct fire as well. Having that UL or CUL stamp, which I have pictured there at the bottom left. It shows the CUL stamp, the number. Anybody who is a UL shop, because you can't just put a label on, you can't just buy these on Amazon or something and stick them on there. Each one is a certified number. You have to be a UL certified shop in order to put that label on. And that number that you kind of see, it's a little bit blurry, but that number, if you type that into the database, that would come up in our case and say, okay, that's a Brewmation panel, and they are a UL and CUL certified shop. UL can come in at any time and take a look at our panels, and just they randomly come in. They come unannounced. They walk in, they go right to a panel, and they start looking at everything that they're building. So it's very strict, and I'm very much for the program, because if we're doing something that's not right, I want to know about it before it goes out. So UL is a great certification for that. The other part is professional installation is something to be considered. In the picture you show on the right that's got the control panel, it's a little bit obscured, but if you look to the left, there's another smaller control panel, and basically that's a disconnect. So the electricians will make sure that what they do is they install the correct wire gauge going to the panel. They'll decide if a disconnect like that particular one is required. And basically that it's a means of getting to the panel and shutting off the power within eye shot of the control panel in the event that something happens. So you may be covered if you have your circuit breaker panels within eyesight, or if there's another disconnect that's close that may satisfy the requirements, but that's where the professional installation comes in. They're going to really know what to do, and you got to make sure you have a good installer. So how much power? This chart is a real nice chart to take a look at. It's going to help when I talked about what your utilities are in your space and deciding on, can you actually do electric? Is that an option? If you choose that is the right option for you, you got to make sure you have enough power. So in this table, and we actually have this table on our website as well, that it shows what the recommended wattage is per tank. So you go down anywhere from a half barrel system, which is 6 kilowatts, down to a 15 barrel system where you can go up to 99 kilowatts. And then what power requirements there are. So if you look and you want to do a 10 barrel system, it's got 66 kilowatts, but it's going to require, you see here, it's 200 or 225 amps. That depends if you put a rake in that system. If you put a rake, you're going to need 225 amps. And we could split that out. It's a 200 amp for the main panel, 25 for the rake if you wanted. But it's only available for 3-phase, because when you're looking at single phase, there's only so much power that's typically coming into the room, and normally those are topped out at 200 amps. So if you look up there, you can get away with a 5 to 7 barrel system on a single phase, but anything after that, you're going to be into the 3-phase. And if you actually have 3-phase, in most cases, you're a lot better off utilizing the 3-phase as opposed to just taking the single phase from the 3-phase, because you want to balance that load on your entire system. So if you have 3-phase, certainly plan to utilize that as opposed to pulling off the single phase. And you'll also get better rates when you're working on 3-phase. The electric company loves balanced load, so you have some better rates there. A couple other considerations: watt density. A lot of folks think about electric and worry about scorching wort, but when a system's done properly, you have the watt density is low enough. You kind of think of watt density as the surface area that is touching the wort. So if in a properly designed systems, we have a proper number of elements, so your watt density is acceptable and you will not get the scorching. So that's definitely something to look at, what that value is, to make sure it is proper. Also, the ability to adjust from 0 to 100%. I've seen some panels out there where you just knock one of the elements off, but then you have the other elements running at 100%. And that doesn't help you when you have a high gravity beer and you're only a quarter way full. You want to be able to run your elements at a very low percentage. So you want that 0 to 100%. I feel it's very important, and that will eliminate any scorching. Element placement as well is something to consider, where they're positioned to get your rolling boil. Other considerations here, some level sensing. You don't want to run the elements dry, so we would typically put in level sensors to make sure that doesn't happen. The bottom one is a tank level sensor. The one above it is a rim sensor. Boil over control is fantastic with electric heat. You're able to really get a very good reaction and response time with electric. Heat ramping is very quick if it's sized properly. The timer start we talked about a little bit, and also remote operation. You could tap into your system with your network, and you could turn on the hot liquor tank before you come in if you don't have the timer set up. So I'm going to go ahead and pass this along for steam, if you want to pop back up.
Guys, this is David Antonacci with Columbia Boiler, and I'm representing the steam portion of this presentation here. So I'm going to take my picture away just so you have a larger screen to view, but I'm still here via webcam or via microphone. Here is steam heating for your brewery. How does steam brewing system work? So a low pressure steam boiler provides all the jacketed vessels that you choose in the brewing system with steam heat. So that's your hot liquor tank, your mash, your lauter tun, and your boil kettle. And the steam uniformly heats the appropriate vessels to a consistent temperature and maintains this temperature for a set duration of time. So however long your brew is going to end up taking, or however long you need that steam heat for, it will continue to provide it. The excess steam in the system and the condensate are returned to the boiler, converted to new steam, and recirculated through the system. And this is kind of where you capture your efficiencies, or one place you capture your efficiencies. What is included in a steam brewing system? So right now what you're looking at is an MPH steam, low pressure steam boiler. You can see the burner on there and the fuel train as well. you're going to get a low pressure boiler, or in some applications, a high pressure boiler, but typically you're going to see low pressure, a feed water tank to feed the boiler water, a blowdown separator for when you are blowing down the boiler at the end of a brew, and a water softener and water treatment system, whether that be from us or a lot of times you'll see it from a local treatment company. So a little bit more about low pressure steam boilers. The primary purpose of the boiler is to supply energy to the facility's operation, as you could have guessed. It could also have a domestic water coil, so you could fill up your hot liquor tank, for example, with that, or provide hot water anywhere in your brewery if need be. Typically these, well, for a low pressure steam boiler, you're going to have a 15 PSI max design pressure, but your operating pressure is typically going to be around 13 PSI. And here you can see a pretty wide range of sizes from 5 to 250 horsepower, which might seem like a lot, probably because typical craft breweries come in the 5 to 50 range. And of course, you're going to have a combustion-based heating source to produce the steam. A little bit about sizing here. Boiler sizing ranges to accommodate brew houses from 7-barrel all the way up to 125-barrel. For a little more information or just some knowledge here on the right side, we have a list from 7 to 30-barrel, and you can see that just looking at the 7-barrel system, you have a 10 horsepower boiler will typically be good for that, assuming you don't have a coil. But if you have a coil for that domestic water, as I mentioned, or you also are brewing in sets of doubles, you're going to need a little bit more horsepower. We're recommending 15. The most common one I think we see is probably a 30-barrel MPH 40 or MPH 50. Actually, maybe more like an MPH 30, 25-barrel system. And as was mentioned in the electric, this is typically just beyond the range of electric or direct or indirect fire. And that's kind of bread and butter for steams. A lot of times with these bigger systems, you're going to get higher efficiency and you're going to get better brewing using a steam boiler. But we do cover that whole spread, as you saw, and then even above that. So why would someone choose steam? Low pressure steam means high efficiency. And we're talking, we get 83% fuel efficiencies by circulating the flue gases through the boiler 3 times. So that sounds a little bit technical, but if we go back here and we look at the MPH here, you can see a burner, that blue burn on the bottom left, shoots a flame across the bottom of the boiler. And then on the right side, you can see that black turnaround. The flame turns around once more and then turns around again. And those 3 passes, there are tubes inside of that boiler. It heats up those tubes, which in turn causes steam to be produced at the top of the boiler. Those 3 passes are in a large part responsible for why you're getting a good efficiency here. Your fuels can vary because not everybody has natural gas. That's typically going to be the cheapest, but there's also propane, fuel oil, and you can run on dual fuel if you even need to. Your operational costs. Gas is more cost effective than electricity in most locations. Sorry, there was a typo there. And you can only brew with electricity up to a certain size typically. After that, the amount of amperage needed becomes too great to justify the price, or you might not even be able to find the service, where most places you're going to find fuel oil, you're going to find natural gas. There's versatility involved with a steam boiler here. A boiler does not require regular maintenance during the brewing, so you can kind of just leave it on its own to do its thing, assuming everything is set up properly. Most of our boilers use 115-volt single-phase power and require less than 10 amps at full load, so you're not really going to have to make power modifications to your brewery, which could be convenient. They can, relative to the steam they're producing and the systems that they are going to be used with them, they can fit a small footprint. They're, of course, reliable, assuming you're treating them right and you're treating your water. And they can range up to 250 horsepower, which supplies 800 pounds of steam per hour, and that's enough to power a 125-barrel brew house. I'm assuming most of you guys are going to be a little bit smaller than that, but hell, you know, with the way craft brewing is going, hopefully we're going to all be expanding and we're going to be having brew houses like that. So why would a brewer choose steam versus anyone else? So out of sight, out of mind, and this is something I see as an advantage when you get into these bigger breweries, is a boiler is typically placed in a separate room. It's not mandatory, but typically it's away from everything, which could leave you more room to leave out your appealing stainless steel brew vessels. Not that there's anything not attractive about a Columbia boiler here, but everyone does like to see the stainless steel and the copper vessels. And the compartmentalization of this equipment kind of allows it to stay safe. So you're not knocking into it, hitting it with kegs, or sweeping dust onto it. It just kind of stays isolated on its own. Brewing with steam is better for your beer. So, of course, with the steam being controlled, the temperature, there's very little chance of caramelization of sugars with steam, and it's transferred through a larger surface area, which is much more controlled over the temperature. I'll skip here the DMS and go down to the heating speed, because of the surface area that it's exposed to, steam provides the fastest kettle temperature ramp-up rates. So you have the sidewalls and the bottom because these vessels are jacketed and the steam is completely encompassing all of that surface area. Additionally, steam has the power to produce a vigorous boil consistently, and a vigorous boil promotes better utilization of hops and boils off DMS, which will the DMS will result in an off flavor in your beer. So here are a couple other considerations, couple snags here that might say, hey, is steam right for me? So you're going to have startup costs. I think that's pretty much assumed based off of understanding you need a steam system. So although running a steam boiler may be the most cost-effective and efficient method for brewing, you're going to have these costs below. You're going to have to buy the boiler. You're going to have to get it installed. It comes with auxiliary equipment, and unfortunately, most times you're going to need building modifications. The system is it's more than just a boiler, as I stated before. So you're going to need to have custom insulated piping, which could be a pain in the butt, but obviously worth it to maintain your efficiencies. And you're going to need ductwork installed for the flue gases to go up. And you're going to need a blowdown separator and a feed water system. So just to breeze over what a blowdown separator is minerals sit at the bottom of the boil. Minerals that are in the water as it heats up will fall down to the bottom of the boiler. And if they remain in there, they'll start to corrode the inside of the boiler, which you don't want for your metal. So what you have to do is you have to blow down those minerals out of the boiler, and then obviously refill the boiler with a little bit of water. A blowdown separator takes that extremely hot steam and condensate and water blowdown, and it mixes it with cooler water so that you're not shooting it right down into, say, a PVC pipe system and melting the PVC. That's not required by law in all states. I know in Pennsylvania for a low pressure boiler, it is not, but it's highly recommended just for the whole system. Additionally, you're going to want a feed water system because this can collect your condensate and also feed preheated up water back into the boiler. Of course, by feeding warmer water into the boiler rather than cold, you're going to maintain those efficiencies you're looking for. Maintenance on a boiler will include the daily boiler blowdown, typically daily, it should be, weekly water column blowdown. The water column sits on the side of the boiler and it helps, it tells it when to switch on, it tells it when to switch off, make sure you're not dry firing, and it has water that's actually circulated in the boiler system. So just like the minerals with the blowdown, you also have to blow down the water column so that minerals don't build up in there and start messing with your level switches. You're going to need an annual inspection. I don't know if that's countrywide or in other countries. I do know in Pennsylvania you need an annual inspection. And you're going to want to monitor your water chemistry and make adjustments there so you don't have those minerals building up inside of your boiler. So here's just some pictures of the boilers we provide. Obviously, there are other companies, but I am a Columbia rep here. So this is our MPH series low pressure steam boiler. There's a blowdown and a feed water system over here. Here are some basic controls that protect your boiler, high water and low water cutoff controls, pressure gauge so you know what you're coming out at, and your burner. Here is a CT series. These are kind of known for being very easy to move around, and they are tall and vertical. They have a very small footprint, but it's worth noting they are typically high pressure, and normally you're not going to see a high pressure system, although if your brew kettle is far away from your boiler, you might need the high pressure, and then you could downstep it closer to the kettle. It's there as an option. Typically, people will get the MPH, but last and not least, here we have a Keystone series, and this is what a lot of people see when they see boilers are these wet back or dry back horizontal boilers here. They're typically, we sell these for the larger systems, 100 horsepower and up. The MPH is kind of unique in the sense that it doesn't have this horizontal look to it, and it's vertical and it takes up a smaller footprint. But again, these are just all options. And okay, now we're going to hand it off to direct and indirect fire here.
My name is Mike Palladino with Stout Tanks and Kettles in Portland, Oregon. First, I want to thank Kevin and David for the presentations they've done. That was really informative. Writing down some notes even for myself. I was a brewer for almost 16 years. Opened a few breweries along the way, and now I'm at Stout Tanks and Kettles helping out brewers. So I'm going to do the same as the other guys and take off my camera so that you can see the presentation a little bit more. So just to give you a little feedback, or history, brewing out mostly Portland, Oregon area for almost 16 years. And I really love this VBC platform that Kevin was the main idea behind this, since we weren't able to really be out with you folks in Texas right now, sharing a beer, sharing knowledge. And the brotherhood that I feel has been the reason why I've been in this industry for 18 years is awesome. Sharing this knowledge is something I really enjoy. I've got a lot of scar tissue on my knuckles, and I just want to share those with you guys to see if we can avoid those on yours. So let's get at it here. Direct fire and indirect fire is really, in a sense, brewing with fire. This is really historically what brewers have done. The reasons why we've done, brewing with fire is because wood has been originally a cheap source of fuel. Over time, there's been more options. Kevin really gave a great presentation about options of electric, if you have the power to electric or prefer electric. Steam as well, with David giving that great presentation there. And then historically, it's fire, and you can either choose to brew with fire because it's your preference, or maybe because of location. Sometimes, truly, the building. What I've learned throughout my time is that the building really determines what the best choice for you is. If you are remotely, out in the country, it tends to be something like a, gas fire, direct, natural gas or propane. And then there's indirect and direct fires. You can see here, and I'll kind of talk about that a little more, but really when you're talking about the difference between indirect fire or direct fire, it's really controlled air. These are pictures right here of more of what a direct fire kettle, very, very, primitive type direct fire, where you have a cooking of the kettle, and there's air that's really kind of, in a sense, giving the source for the fire to keep alive, and it also kind of affects the flame. The picture on the right is me when I first started brewing. I'm just, at least my assistants would think that, being around. So let's move on. Direct fire. Again, really what this is talking about is the controlled air around it, or not controlled air. With direct fire, we typically at Stout will build these up to 10 barrels. We have gone bigger. My preference is indirect fire, which I'll kind of get into in just a second on this. But the thing about the direct fire is really what you're doing is your burner, as you can see on the left there, a mount for where your burner would be mounted. And so what you're typically doing is cooking the bottom of the kettle, cooking the steel or the air around the kettle. That will then transfer through the metal into the liquid, whether it's your wort or your water. This ends up being less efficient when you're talking about BTU efficiency transfer. Gas may be cheap, but you tend to have to use quite a bit more BTU power to get that transferred into your liquid. The picture on the right is that same kettle, but it has a kind of heat shield skirt basically around it, but it still has to allow airflow since there's not a controlled air. Since there's combustion, there's byproducts that you have to kind of think about. Carbon monoxide being one of the main ones, heat, excess heat coming into your brewery. And these are things that you're going to have to pay attention to. You may have to do some makeup air to get the proper amount of ventilation. Is put in a lot of breweries personally, and sometimes these can be tricky if you have poor ventilation or negative air pressure in your building. You really have to kind of pay attention to that. Design your brewery with either makeup air or some louvers, windows that you can bring in more air. And then there's venting of the gases. You need to get those gases vented up and out. You can see on the picture on the right that vent on the top is more just a condensate stack for the condensation. On the back side of that heat shield, there's going to be typically a hole where you're going to try to pull like a little bit of those vents up, excuse me, the fumes up, or you're going to have like a big hood fan. That could add thousands of dollars to your building project for the brewery. So it's something you want to take into consideration. The next slide we'll hit here, and we typically go up to 10 barrels on these things safely. My preferred choice, if you are going with fire, natural gas, or propane, are the two common, it just depends on where you're at, is indirect fire. And here's an indirect fire kettle, and what we've done is taken the firebox open so that you can see the far right is refractory brick. So what you have on the middle portion there, the zoomed in, is where your burner will be mounted. And so now what you have is controlled air. Your burner has a fan, which is going to force it's going to force the flame into that burn chamber, where it's going to now allow the air and the excess air, any combustion itself, that besides the heat going into the steel and the air around it, is going to allow the venting on the left picture that you see coming up and out. So at this point, it's a lot safer for your brewery, your brewers, the area around there. There's no combustion gases that are being exposed to the brewery or the brewers. There's less heat going into the actual brewery. So the flame is really actually underneath. It's not as a true indirect where it's in another room like a heat exchanger type thing, but what it does is it really controls your airflow when you say indirect fire. The refractory brick is great because there's much more insulation. These kettles are a little more expensive for sure and heavier. Recently I had someone get their tanks, and they called me up because once they were trying to get it off with a forklift and they realized, they called me and said, "What did you do? Put rocks in here?" And I laughed. I said, no, we did one better. We put brick in there for you. So they are beefier, they are heavy, more efficient. The direct fire efficiency is anywhere between 50-60%. Indirect fire, you're going to be much more into the 70s and 80s, depending on how good and fuel efficient you keep your fuel lines in your burner. The things that I like about the indirect fire as well, less quiet, more quiet. You don't have the noise of the burner going through any kind of inspections or initial any kind of inspections to get passed for locally are typically a lot easier done with indirect fire, because it's the flame's controlled, the gases are coming right up in here and out. When you have direct fire, depending on where you're at, there could be questions that some people want you to go through extra steps to do your venting. So it's just something to think about. The heat up time is going to be, better on your indirect fire because of that insulation. Direct fire, you just have to turn that burner even more, higher and use more gas. But if you're either choosing, flame for either two things, either because it's your preference or because of your location, you can, have those options of either direct fire or indirect fire. There's even hybrids. I really like the hybrid style system. Kevin can talk a little bit, maybe about the timers, but it's nice because you can put a timer on your hot liquor tank and have an electric hot liquor tank, and then have an indirect fire kettle if you really prefer to brew with fire. So let's see, the next one we have here. Oh, cheers. Hey, thanks, guys. I want to kind of more say thanks a lot for this opportunity. I miss seeing fellow brewers and stuff like that at these gatherings, but at this point, I'll hand it back to Kevin to continue, and then I think we're going to have maybe some time for questions if we do. So thanks a lot, everyone, for being here.
Excellent. Thank you, Mike. That was great. All right, so I'm going to take so you guys can see this a little bit better. This is an interesting, we get the question quite a bit, and this may spur a lot of questions and maybe even spur some controversy. I don't know, but that's not the purpose here. The first thing I'm saying here when we start comparing all three of the different methods is that it is difficult to draw an accurate comparison because there's so many factors to consider. But since we get a lot of questions, we wanted to kind of put a table together that gives a general overview on average. But I will give that, the fine print here that a lot of these can be switched around based on individual circumstances. So basically, the chart on the right is using averages, and we're looking at fuel used can definitely vary these results. Natural gas versus propane, electric rate, demand charges, if you have them, can also change things around quite a bit. Talk about that in a sec. Obviously, brewery size and even locality. I believe the two states, at least two states, Texas and California, will require the steam boilers to be low NOx boilers, and that's obviously a consideration that can sway one way or the other. But when we look at efficiency and just pure efficiency of BTUs being transferred, as we discussed, electric, because you're transferring, when you do have immersion heaters, you're very close to 100%. Someone asked in the questions, what the possibilities are for an electric steam boiler, and absolutely, that is definitely a technology. We offer that as well. So electric boilers are definitely a nice choice if you did want to use electric, and you just really wanted to have that steam for your brew kettle. So, but steam generally is going to be depending, definitely in the 80% range. Direct fire, is the last in the efficiency, as Mike pointed out. You're looking at maybe 50-60% on a direct fire. Indirect fire, though, starts approaching into the steam territory, but certainly is under the steam. Energy cost, this can really swap around in all sorts of different ways. In most of the studies we've done with customers, because customers ask us, okay, what's my energy cost? You have electric, steam, and direct fire. And this varies widely on, where you are. Electric could be the worst one. As an example, in the Caribbean, their electric rates are through the roof in most places because they're running off of generators and such. But you could be somewhere where electric rates are very low. The 20-barrel customer that we designed, or haven't installed it yet, but they live, their brewery's right next to a power generation facility, so they got some really great power costs. So they wanted to go electric. So energy cost, generally though, when we do them, just in general areas, New York, California, anywhere that it's kind of average energy cost. Steam is typically a little bit lower than the electric. So steam, as far as energy cost, tends to be the lowest. Direct fire, indirect fire is certainly becomes the higher cost on direct fire because of the inefficiencies. But if you have an indirect fire and you have some great natural gas rates, then it can fall back in line as well. So definitely energy costs kind of sway quite a bit. So it's kind of tough to put some accurate dots on there. Capital cost, when we look at that, most of the time direct fire will be the lower capital cost. But that really does depend, because if you're looking at what's required, you may end up putting in some pretty expensive fume hoods, things like that, to get some of the emissions out if you're not doing indirect fire. But certainly on average, a direct fire system is going to get you in to the scene at a lower cost. Electric would typically be second, and then steam being the most expensive, typically because as it was mentioned earlier, that sometimes you have to do some building modifications. Sometimes it's a different room that it has to be placed in, and also that you're looking that could be a bit costly is having a steam fitter come in to run the lines. If you're nice and close to your brewery, that could be a much lower cost. But if you're further away at a different level, those costs can add up. So that's a pretty good average, but it does depend. The electric I have in there as capital cost as number 2, but you have to start running 3-phase a couple miles down the road, then that's certainly going to be a red dot there. Fast response time. This is a difficult one to answer. This could draw some folks to disagree. Maybe, I'm not sure, but on the electric, you have a very quick response because as soon as you turn off the electric, especially with boilovers, you get an immediate response on the power feed, and you could see it. Like as soon as you turn it electric off, your boilover just sinks right down to level. Direct fire, I have that in there as a number 2 for response, because the same thing, you're turning your heat off. You could shut off your flame immediately, and now you're looking at the residual heat that's in the steel that has to be transferred into the liquid. So certainly is going to be a slower response than electric because of that steel. I have steam as number 3 because not only do you have that steel heat, but you have to now cool down the steam, that's condensing, and transferring phases inside the jacket. So, the response time there is going to be slower. Again, some things can change up there on system designs and so on. So, again, this is kind of an average overall look. Fast heat time, as it was discussed during the steam segment, that you do get a nice fast heat up with steam. Especially due to all the surface area. Electric we have there as a close second. A lot of folks think about electric that it takes forever to heat up, but I have to say that when the system's designed with the proper wattage, we get it all the time. I knew you told me it was going to be fast, but man, I was surprised at how quick it did heat up, because if you have to really properly size it and have a properly designed system. So it depends on how much power you put into it. You can get some very quick response and heat times. And direct fire is kind of officially have this as the 3rd one. And the only reason you can certainly on a direct fire get things to heat up pretty quick, but you're losing so much energy to the atmosphere that, the surroundings, that it could certainly take up quite a bit of time. Indirect fire is going to be much better. So that could certainly increase that, that rating. Automation potential. The electric, like I mentioned during my segment on electric, is very easy to automate. We introduced PWMs, which is called the pulse width modulation, to be able to run those elements anywhere infinity from 0 to 100%. You could turn them on and off remotely. You can turn them on and off when no one's there. So there's a lot of automation potential because you're dealing with electricity, which is very predictable. I have steam at a close second. Steam, it depends on how you have it set up. If it's just done with manual valves, then you really don't have much automation on that at all. When we do the control systems for the steam, we put motorized globe valves in so that we could vary, again, that infinity adjustment from 0 to 100%. So you certainly have automation potential with steam as well. Direct fire, it depends on how that's set up. The majority of the direct fire systems that I see are on-off control for the burner, and that can be automated. As soon as you hit your temperature, you shut off the heat, and then if your temperature drops below the set point, it turns the burner back on again. But there's also more so in indirect fire, there's modulating burners. So same thing, you can actually get a nice, I wouldn't say 0 to 100% because you don't want to. Typically when you're running that burner, there's a low point, but you definitely get that variation, and we could send an analog signal of 0 to 10 typically to the burner and run that up and down. So there is a level control there, but typically they're straight up on off controls. As far as simplicity, we went ahead and rated the direct fire as the most simple to use, only because I think a lot of folks who are coming from homebrewing who are used to direct fire, it's a pretty straightforward way to go. Fairly easy to set up, although when you start getting into the makeup air, et cetera. The install could be a little bit more complex, but as far as utilizing it, everybody's very familiar. You see flame, you got heat. It's really easy to run. I got electrical there as a close second. Basically turn the switch on, you're getting heat. Especially with the automation, it could be very simple to use. Not to say that steam is not simple to use either, so don't take me wrong there. Just a little bit more complicated because you're dealing with steam lines and your pressures and what your pressure is hooked up to. So there's some things to consider there.
There's Kevin's mic here.
I talked about it as an average, and again, I'm sure that there might be some different thoughts on that. So anyway, we'll go on to some questions here. Maybe we could all join back in and for questions. All right. So one came up here. Electric is measured in watts, steam and horsepower, and fire in BTU. How do you compare systems by output? Typically, I'll convert any of those numbers. So you got watts is direct correlation to BTUs, as is the horsepower, which you could look at pounds of steam. And then direct fire is BTUs. So when we do the comparison, we always get everything onto a BTU level and then just take the efficiencies and losses into account and go from there. But you guys could chime in on that one too. But
Yeah, so completely agree.
You got it, Tom. No problem.
Okay. Do you guys tend to see breweries avoiding steam systems in zoning restrictive areas? So I am kind of new to this, so I don't want to answer with extreme confidence. However, I do know that I have seen people in Philadelphia say that they're trying to avoid steam for reasons similar to that. However, if I had to guess, I would say that's probably dependent on where you're located. And Kevin, I'm sure you have more experience than myself, so maybe you could answer that as well.
A lot of times when I see that come into play, would be in the low NOx category.
Right.
And California, I think Texas. Are there any other states that need to really be cued in on that? I think there might be a province in Canada too. But you have to make sure that if there's some requirements for the emissions, then you end up getting into a low NOx burner, which is going to be under the threshold that's required. And it's very important, especially California, Texas, to think about that, because you don't want to put in a burner and have them reject it. You have to take it out or replace the burner. I'm not sure how complicated that is or not.
I also see issues with flue gases in terms of letting them out. Well, yeah, I guess that's kind of what you're saying. Letting them out in vicinity of another building. So whether or not low NOx in discussion, just in general, letting those gases out.
Yeah, a lot of times the penetrations in the building, when you have an exhaust, steam is typically not that much of a concern, but when you're exhausting for a boiler or exhausting for natural gas, direct or indirect fire, those penetrations sometimes have to be permitted or considered. So that's something to take into consideration. You definitely want to go outside with that. But a lot of times we've seen on the front of people looking to decide, say, well, I'm just going to go with electric because it becomes way too complicated for me to get my CO and whatnot because of the penetrations into the roof. So yeah, that's a good point.
Yeah, I would, if I could chime in, just say there's definitely, you want to do some research before you get in. Kevin and I have helped out somebody recently who actually purchased a steam system, went to go put it into a place in California, and they thought they were all good, but it's actually a very high traffic shopping mall. And so they gave us a call and we scrambled, and Brewmation and Stout worked really hard together to get them an electric system, because all of a sudden they were told by the facility, hey, you can't put a boiler in here because of all the restrictions. So I think you just have to make sure you do a little bit of your research before you start going too deep, because really the building, in my mind, the building determines really what the best option for you is. After you've kind of figured that out, then it's just a little bit of, research. Hey, do I have to vent out steam? Do I have to vent out gases? Or can I just turn the steam to vapor and go to a drain? So.
Yep. And all right, got another one here. Go ahead. Yep. before we get into that next one?
Just in terms of your comparison chart, I think I do agree with that pretty strongly. Although I think my manager, who's been with Columbia for a long time, might give you some pushback. I would say that that's really accurate below, let's say, 25 horsepower, but then, or below, let's say, a 30 barrel system. But it's going to be harder with electric once you get to those larger sizes, or it's going to be harder with direct fire as well. So in terms of a steam boiler, that's really the bread and butter there. Is if you have a bigger system or you're upsizing, that's kind of when a lot of people come looking for us, rather than the 7-barrel system, which of course a direct fire, indirect fire, or electric are going to be cheaper, quicker, easier, probably more efficient as well.
Yeah, absolutely. That's I 100% agree with that. Great input, Mike. Appreciate that. So one came in here, how many kilowatt hours do electric brew houses use? And obviously it depends on how large the brew house is and how big the system is. The calculation is fairly straightforward to do. When you look at, if you have a 30 kW system, that's basically using 30,000 watts, so 30 kilowatts per hour. So you could do the back math on that to see how long it's going to heat up your hot liquor tank, and then how many kWhs you're using on that. Depending on if you're using a Herms, you're going to have a little bit of a higher of maintaining wattage that's used. So we usually stick a percent in there. That's pretty small, maybe just running about 10% on that. And then if you're doing an hour boil, hour and a half boil, that's a straight calculation. Typically we're going to be running those elements depending on the size, but it could be 60, 70% during the rolling boil. You may in the first heat up stage go at 100%, or at least ramp up to 100%. Then when you get your rolling boil, you're going to back off on it a bit. So you really want to dig into what size brewery you have and what that usage will be. Certainly reach out to me, and or John or any of our guys here, and we'll run that calculation. We'll even send you our spreadsheet that you can play around with the numbers. So we have a nice spreadsheet that takes all that into consideration. You can type in some of the variables and it'll tell you what your usage is, then you can put your cost in and know exactly what your cost per batch will be. It's surprisingly low when you look at it, what your cost per batch. So. All right, I think there's let's see here. There's another one here. Hit the button. I know there are different installation costs associated with different systems, but is there a resource that breaks it out to dollar utility cost per batch if you compare the different heat sources? Yeah, absolutely. Especially I know myself and Mike can certainly help out, or any of us from our companies. We offer all three technologies, and we have the comparisons, and we do that all the time. We work through that. So we want to make sure that you make a good decision. There's a lot of considerations, and we'll go through that with you. So we would be an excellent resource. There's probably some other resources out there as well. So certainly do a search on your Google search, and I'm sure you'll find some things. But we'd be happy to share some of our spreadsheets and everything.
I would highly encourage everybody on here to feel free to follow all of us here on Instagram and social media and see what we post, and we'll follow you guys back, because it's a tight community and we just want to maintain that.
Excellent. So we have a minute and a half to finish up. I can't believe the perfect timing here. This is great. You see popped up there. If you have some more questions, click there to schedule a one-on-one. You could do that with any of the three of us or any of the other presenters. We all slotted the time to be in Texas, so we're here to chat with you. So don't be shy. Go ahead, and if you really want to dig into some of this, go right on in and click on that and schedule something with us. We'd be happy to talk to you. As you know, we've been talking to you for an hour, and we have no problem doing that. So click on that, and we really appreciate your time, and thank you so much.
Yeah.
Thanks everyone for listening in.
Yeah, thanks a lot, guys. This platform has been refreshing to see the camaraderie and the brotherhood. Really passing that karma of knowledge on, because that's the reason why I'm here. People helped me out. They shared knowledge with me when I was younger, and if we kind of keep passing that out, that's going to be better for our industry. So thanks a lot, guys. Cheers.
Yeah. Cheers, everybody.